Hello, ladies and gentlemen, and thank you for joining this webinar. We're going to discuss Microsoft Windows Azure SQL Database security. I'm going to mute all attendees during the presentation. You will have plenty of time at the end of the webinar to ask any questions you may have. And if it works for you, you can also use the questions panel in GoToMeeting. If not, just write down the question, and as I said, please do ask it at the end of the webinar. The slides will be available for download within a few days. We will be sending the slides to the attendees of this webinar. And I would like to go ahead and start with the agenda. The agenda for today is to describe the Windows Azure SQL Database security capabilities and available resources provided by Microsoft. We're going to discuss in details the best practices for securing a SQL database. We're going to try and understand what Windows Azure SQL Database customers can do to understand what's happening within their databases. And then we're going to talk about advanced security measures that you can take on Windows Azure SQL Database using GreenSQL. And as I said, we'll have plenty of time for questions and answers. So before we really start, I just want to talk a little bit about the terminology. So Windows Azure basically is Microsoft's cloud platform. It includes 3 layers of cloud services. It's a software as a service, it's a platform as a service, and recently Microsoft added infrastructure as a service, so you can add your own servers running on virtual machines, upload them to Windows Azure, and have your applications and data fully hosted on Microsoft Cloud. So Windows Azure is a general name for the whole platform. Microsoft called the hosted database SQL Azure, but starting June this year, they decided to name it Windows Azure SQL Database. So that's a longer name for what was previously called SQL Azure. And it is part of the features that are called Windows Azure Data Management features. They also include business intelligence, data synchronization, and other features. But SQL Database is one part of Windows Azure feature set. That being said, you can also run any version of SQL Server on a virtual machine that you upload to Windows Azure. But that is not called Windows Azure SQL Database. It's simply a virtual machine running on Windows Azure. What is Windows Azure SQL Database? It's a SQL Server engine on a relational database management system that is based on SQL Server 2012, the latest version of Microsoft, codenamed Denali, but with a few restrictions. We're going to discuss that in details later. In terms of security, what we've seen introduced in SQL Server 2012 and migrated to SQL Azure are new server-level roles, improved hashing algorithms, and additional permissions. One additional major feature that was added is contained databases, and we're, as I said, going to discuss that in more details later. And there's some more security management enhancements added into SQL Server 2012 and migrated into SQL Azure. Main restrictions, there's many more restrictions, are server auditing, which is supported in on-premise installations of SQL Server, but are not supported in SQL Database. The authentication modes, So you can only use SQL Server authentication on Windows Azure SQL Database. And switching between database using the use command is also not available in SQL Azure. More details later today. You can see the full list of restrictions. If you just follow any of these two URLs, you go to Microsoft's website, and there will be a full list of restrictions that you will be able to understand the limitations of SQL Azure. So just after the webinar, click on those links and see for yourself what you can do and what you cannot do with SQL Database on Windows Azure. So starting with security best practices, in general, all the security best practices that apply to any database and specifically to any SQL server also apply on Windows Azure SQL Database, but the specific best practices that I would like to focus on during these presentations are the network protocol, limiting the TCP/IP port, keeping all the software up to date, configuring Windows Azure SQL Server, Windows Azure SQL Database firewall, and talk a little bit about general best practices. So in terms of SQL Database clients, SQL Database on Windows Azure runs only on port 1433. So you must have this port open for outbound connections for TDS protocol. TDS protocol is the TCP based protocol that is used by Microsoft SQL Server. It stands for Tabular Data Stream. So you must open port 1433 on every client application accessing SQL Database. But what you want to do on the same time is to block any inbound connections on that port. So you don't want to keep that port open both sides. You just want to keep it open for outbound connections. One of the main advantages of SQL Database on Windows Azure is that since you don't maintain the database yourself, Microsoft is taking care of maintaining the database. They constantly update the software. So they do that every couple of weeks. They update the version of the SQL database to the most up-to-date version. So whenever there's a security patch or a fix, they will apply it as soon as they can on your databases. So you don't have to take care of that yourself. Having said that, you have to take care on the clients, on all of the applications running against Windows Azure SQL Database. So you have to make sure that if it's ADO.NET or if it's SQL Server Management Studio or if it's any other application accessing SQL Database, you have to make sure that it is always up to date. First, because you want to make sure that it supports Windows Azure SQL Database. And second, because if there's any security fixes applied on clients, you also want to make sure that you have those fixes installed on your applications as well. We'll talk on configuring Windows Azure SQL Database firewall and a little bit about general best practices. So there's many possible vulnerabilities to SQL Server. But what you can do to prevent these vulnerabilities is to plan before you deploy the application, to prevent SQL injection vulnerabilities during coding. So there's a lot of best practices on how to sanitize input strings, input parameters, how to use store procedures correctly to prevent attackers from filling in web forms and hijacking the database using SQL injection. So that is being done when you code the application. And you can perform regular penetration testing before deploying the application and the SQL Server to the cloud on Windows Azure SQL Database. I'll talk a little bit later about what you can do in terms of penetration testing on Windows Azure Cloud. Let's talk a little bit about the encryption and certificates introduced in SQL Azure. So to be very, very cautious and to be very secured, Microsoft enforces all the communications between client applications and Windows Azure SQL Database to use SSL, Secured Sockets Layer. So the login, the handshake, and the the continuous work against SQL Database has to be encrypted and has to be using SSL. This is basically employed because you want to prevent man-in-the-middle attacks. You want to prevent hijackers putting software between the application running either on-premise if you're working in a hybrid environment or on Windows Azure Cloud and the SQL database. So all the communications is encrypted and secured using SSL. All the applications working against SQL database need to explicitly request an encrypted connection because of this precaution. So you must make sure that your application supports SSL. You cannot, or I would say you don't want to trust the server certificate. So SSL is based on the server certificate and client certificates, but you don't want to trust the server certificate because if you do that, any software residing in the middle between the application and SQL database can perform a man-in-the-middle attack. So if your application does not request an encrypted connection, SQL database will still send you one, but if you don't validate the server certificate, then anybody can hijack the connection and see the communications between your application and the SQL database in clear text. So just make sure that you use the certificate correctly. In terms of authentication, again, to enforce security to be much more strict, Microsoft does not permit to use Windows authentication, so you must use SQL Server authentication only. That means that you need to define the connection strings in your applications to use only SQL Server logins. So you need to take that into consideration when you migrate applications to Windows Azure SQL Database. All the logins, all the users must provide credentials every time connecting to Windows Azure SQL Database because it is a SQL Server authentication mode. That means the login and password should be provided with every connection. And as I mentioned, to switch between databases, you cannot use the use command. You will receive a warning message from Windows Azure SQL Database, and you will not be switched to the database that you wanted to. You need to specifically disconnect and connect to the specific database that you wanted. I would say that the best practice here is to connect to the specific database in advance during the login and not doing disconnects and connects because of performance reasons, not essentially due to security reasons, but that will save you the time and the efforts of disconnecting and connecting to the right database. What happens when you change passwords? So in a regular SQL Server environment, when you change a login password, SQL Server will automatically re-authenticate all the existing sessions, and the sessions that will send the old password will be disconnected from SQL Server. In Windows Azure SQL Database, this is not the case. These connections will not be immediately re-authenticated, no matter what, always. And it will only happen after a timeout of 60 minutes from the last re-authentication attempt. So the request that was sent by the client application to SQL Database following the 60-minute timeout will need to re-authenticate against the SQL Database. Again, if that application still uses the old password, then the session will fail and will be disconnected from the database. In terms of logins and users, there's many more restrictions that apply. I encourage you to read the Microsoft MSDN documentation. The main restrictions that I want to mention are that the database user in the master database is the one that corresponds to the server level principal login, cannot be basically changed or dropped. There is an equivalent login to SA in Windows Azure SQL Database. It's not called SA in SQL Database. There's a different administrator. If you do want to access the master database, every login must be mapped to a user account that you've defined on the master database. That basically applies to any other database that you need to map users or logins to the specific database that you want to authenticate the users against. If you do not specify the database, you will be connected to the master database by default. Basically to perform any administrative command to drop or change logins or databases, you must be connected only to the master database because these are administrative commands. Now I want to spend some time discussing contained databases. Contained databases is a new feature added by Microsoft in SQL Server 2012. Basically, it means that the database includes everything needed to move it from one server to another server. So even if it's not a master database, you can take the database as is, move it to another server. So all the necessary security and system definitions, data dictionary, etc., reside within the database itself, and the master is not necessarily needed for migrating the database. Windows Azure SQL Database is a fully contained database by nature because it employs a multi-tenant environment. So you may be running your database together with other customers on the same server or on the same machine. So and Microsoft may move it from one server to another because of performance, security, replication reasons, to make sure that you will always get the best performance and the best scalability and availability over databases. So all the databases are contained by nature, and Microsoft takes care about locating the databases in the right servers. So saying that, it bears some restrictions or some best practices that you must be aware of. So SQL databases have to, you need to scope them to allow users to consume database level assets. So you need to work on a database level granularity when you scope users. You don't want to work on the whole server level because migrating the database will not work correctly in that case. Um, Having SQL Server contained database functionality in SQL in Windows Azure SQL Database is the reason why you see many on-premise or regular SQL Server installations capabilities not available yet in Windows Azure SQL Database. The assumption, according to conversations with Microsoft, is that many of these features will be added to contain database implementation and therefore will also be available in Windows Azure SQL Database. So that's kind of gradually being applied on contained database implementations and migrated to Windows Azure SQL Database. Another interesting security addition that Microsoft introduced together with Windows Azure SQL Database is the Windows Azure SQL Database Firewall. It basically access grants based on the originating IP address. So the default when you create a new instance and a new database of SQL database is that nobody can connect to the database. So any access is being blocked by the SQL database firewall. What you want to do after you've created the database is you want to start and adding list of IP addresses or ranges of IP addresses that the client applications originate from, and then the SQL Server, the SQL Database Firewall will allow these clients to connect to the SQL Database Server or databases, depending on the level of firewall rules that you define. There's two granularities right now. As I said, it's limited only to the originating IP address. So it's just kind of an access list firewall based on originating IP addresses. There's nothing more to it right now. There's the server level firewall rules. They restrict access to the whole server, to all of the databases within the server. These rules are stored in the master database of the server. And you can configure these rules via different ways. You can use the Windows Azure Platform Management Portal. There's a URL that allows you to manage all of your SQL database, all your SQL databases. It also has the SQL database firewall capability as part of the management portal. You can use a REST API to define firewall rules on the server level. You can also use system store procedures and views to view and change firewall rules. Again, they're defined only in the master database. The names of the store procedures are here. So sys.firewallrules is a view that allows you to see the existing rules. Setting rules is done via SP set firewall rules, and deleting rules is done via SP delete firewall rule. You may want to look in MSDN for more details on these store procedures. If you care about specific database level access rules, so you want to, you may want to use database level firewall rules. This is, by the way, a new addition by Microsoft from the last couple of weeks. It didn't exist up until August this year. And database level firewall rules restrict access to individual databases within a SQL database server. So even if you define the IP range or IP addresses allowed to access the server, you can do it or have it defined on specific database levels. The rules themselves are stored in each database itself, and they extend the server level rules. So when you connect to a specific database, the Windows Azure SQL Database Firewall will examine the database level firewall rules because they have more importance than the server level firewall rule. You may not want to use it at all. So the only thing that you must do is you must define at least one server level firewall rule that will allow the applications to connect to the server, and then you may be done with that. But if you do want to get down to the database level, there's system store procedures on each specific database and views that allows you to see and set database level firewall rules. And the following diagram is taken from Microsoft, basically explains how the Windows Azure SQL Database firewall works. Basically an application is connecting to Windows Azure. It first meets the SQL database firewall. If there is a server level firewall rule and the IP address is in range, then and there is no database level rule, then you are fine and you can access any database. If there is a database level rule, then your rule is matched against the originating IP address is matched against the rule, and if everything is fine, then you're granted access to that database. This is how it looks like. I have here a server level firewall rule allowing me to access my SQL database server from the outside world to the cloud. You can see 2 IP addresses allowed here. What you can see at the dialog below is what happens if I'm trying to access Windows Azure SQL Database from an access that is not allowed. So you will get a detailed error message telling you exactly how to configure that to allow or to add this IP address to the list of allowed IP addresses. What you cannot get, at least at this stage from Microsoft, is the list of failed attempts trying to access your SQL databases, which may be potentially an attack or an attempt to connect and hijack your data. So this is something that is not currently provided and may be on Microsoft roadmap, but currently you cannot get that. There's a lot of more documentation on the web. I encourage you to look at the current compliance and regulations that Microsoft has been certified on. There's this portal here that basically lists the list of regulations. So if you care about HIPAA or PCI or PII, then you may want to look at this URL. There's a list of the exact regulations, and looking at this list during the last couple of months, I can tell you that Microsoft is constantly working on updating and adding more and more certifications to Windows Azure. The only thing that I can tell you right now is that there's no specific compliance to SQL database. So it's still behind, but according to Microsoft, they're working on adding compliance also to the SQL database on Windows Azure. So just, follow up and check this URL often. You can also carry out authorized penetration testing on Windows Azure. So if you want to deploy your application and before you really put it into production, you want to carry out penetration testing that are coordinated with Microsoft, there's a form that you can fill in, and Microsoft will provide you a window of time and a list of IP addresses that you can carry out authorized penetration testing, so you can do some pen testing on your app. And you can also look at the Windows Azure Trust Center, which is a general resources page to any data on the on Windows Azure security, so you can get a lot of more data on this page as well. So having described the SQL database security capabilities plus the best practices, I want to kind of explain how you can extend these security measures and basically feel more comfortable migrating your applications to Windows Azure, and specifically using Windows Azure SQL Database on Microsoft's cloud platform. So if you follow all these best practices and employ these practices on your environment, you still have some security measures that you may want to take, and GreenSQL allows you to complete and get much better protection on your data. First, by complying with regulatory compliance. Second, by getting protection from SQL injection attempts and from data theft. I will explain a little bit more about GreenSQL in the following slides. GreenSQL is a software-based reverse database proxy. It's web-based. It's very easy to install, maintain, and use. It is certified on Windows Azure, so you can install it on Windows Azure. And it is available for a free trial. If you follow this link, you can download and install GreenSQL both in a hybrid environment and on Windows Azure Cloud. It also supports SQL Server 2002 2012, codenamed Denali. There's also support for MySQL and PostgreSQL using a single installation. The way GreenSQL works is on Windows Azure. So you install GreenSQL on Windows Azure on Microsoft Cloud. GreenSQL intercepts the traffic between both on-premise applications, if you're using cloud bursting or a hybrid model where you have your applications both in the cloud and on-premise. So you can see here 3 different applications running on-premise and 2 applications running on the cloud. GreenSQL intercepts the traffic, examines the traffic, provides security and protection and auditing for compliance, and sends the traffic, if required, to Windows Azure SQL Database. So it is very easy to install and use on Windows Azure. And as I said, it supports both hybrid and fully hosted architectures. It is done within a few clicks. So you just define your SQL database on Windows Azure. You redirect the applications to work with it, and you're instantly protected, and you can add some auditing policy to comply with regulations and see exactly what SQLs are running against the database, what are the login attempts, those who succeeded and those who failed. And you can generate, of course, valuable reports based on this information. A little bit about the 4 pillars of GreenSQL. So GreenSQL provides database security. It has an active SQL injection prevention engine. So if the engine detects that a SQL injection is going to be sent to the database, it blocks. You can close the connection. You can generate an error. You can return an empty result set. It is a full database firewall. It provides a full separation of duties. As I mentioned, the Windows Azure SQL Database Firewall only limits users from certain IPs to connect to the database, but with GreenSQL you can limit access for a certain user, for a certain application within a certain time frame. You can limit DBAs from accessing the application data. You can do a lot of day-to-day separation of duties tasks with GreenSQL. And as I said, it's a full database firewall. It's not only based on IP. IP is only one of the criteria that GreenSQL considers when deciding whether to allow a connection or a SQL to be run against the database. GreenSQL also provides an active database activity monitoring to comply with regulations, with reporting and alerting. It also allows you to see the before and after images of the data. So if there's a data modification attempt, GreenSQL will record the before image of the data and the after image of the data, so you can compare to see if there has been an attack, to see exactly what has changed. GreenSQL also provides dynamic data masking capabilities. It can hide sensitive data such as credit card information, personally identifiable information, email addresses, or any other valuable information. It is dynamic in real time. You don't have to change anything in your database schema or any line of code in the application. And GreenSQL can also provide you with performance acceleration by offloading database requests with database caching technology. So if you have a distributed application, GreenSQL can record executions of same queries, and if the data is still deterministic and nothing has changed, you can get the data from the cache copy much closer to the application without the need to access the database. And by using these 4 pillars, basically you get a full protection, active protection. You get a full database activity monitoring, understanding what happened in the database, any login attempts, any administrative command, and any SQL ran against the database. And you can, of course, generate reports based on this information. So to summarize the concept between the concept of SQL database security and what is provided by Windows Azure SQL Database today, and how GreenSQL can complement that, I want to focus on a few major use cases or security concerns. First is compliance and regulations. As I said, there is no server audit in Windows Azure SQL Database. It is very limited. You don't see when there is an unsuccessful login attempt. And by many of the regulations, auditing must be provided by a third party, not by the database vendor itself. So you usually want to use a third-party tool according to these regulations. GreenSQL provides you with a full administrative and SQL granular auditing and before and after image of the data. One of the major security concerns of any application using database is SQL injection. So Windows Azure SQL Database, similarly to any SQL server, does not provide you with SQL injection protection. GreenSQL provides you with the full SQL injection protection by examining each and every SQL running against the database and blocking SQL injection attempts. Separation of duties is very limited in Windows Azure SQL Database. And you can do some with database roles, so you can define logins and roles, who can access what information. But these rules are based on database capabilities. They don't include a combination of IP addresses, users, application, and databases and schedules. GreenSQL provides you with a full engine that allows you to separate duties between different users, DBAs, auditors, and users of the applications, and it's based on a variety of criteria. In terms of a complete database firewall, as I described, SQL database firewall is limited only to IP addresses. GreenSQL complements that and a blocked attempt before they even reach the Windows Azure cloud. And there's a lot of criteria that you can base the firewall rules on. And you can do customized actions, so you don't have to just close connections. You can return an error message, which is customized. You can return empty result sets, record people who tried to run a SQL injection attempt, but return an empty result set in this case. So this is very customized. Database patching is less of a concern, as I described, because of Microsoft frequently updating the database. They take care of the correctness and the freshness of SQL databases in Windows Azure. However, GreenSQL provides you with virtual patching, so there's a window of time between a vulnerability was published and the database was patched or updated. GreenSQL provides you with virtual patching, so any new SQL injection attempt will be immediately patched in GreenSQL and provide you with protection. In terms of dynamic data masking, there is no data masking in Windows Azure SQL Database. GreenSQL provides you with dynamic data masking, so which is very flexible, so you can mask sensitive data, allow only, for example, an auditor to see some of the sensitive data, but users of the applications cannot see full credit card numbers or personally identifiable information. If you want to have a single solution for hybrid and fully hosted applications, so you have parts of the apps on-premise and parts of the apps in the cloud, Windows Azure SQL Database provides you with this only database firewall protection. GreenSQL provides you with a one management interface with flexible policies that apply on both on-premise and cloud installations. And the last point is limitation of direct database access. So Windows Azure SQL Database is segregated. You don't have access to the host hosting the SQL database. So you cannot do anything physical to the database. You cannot delete files or change data by logging into the host itself. However, GreenSQL complements that by being a reverse proxy and examining any SQL and any connection attempt before they even hit the database, also providing you with a performance acceleration. A little bit about what's required to install GreenSQL. You can install it on the medium-sized compute instance on Windows Azure. It's basically 2 CPU cores and 3.5 gigabytes of RAM. You can install it on a Windows or Linux server. We recommend Windows Server 2008 R2 64 bits. The management is web-based. All major browsers are supported, so you can access GreenSQL from anywhere to view reports, to define policies, etc. And the installation is flexible. You can install it. It's a software-based installation. You can install it either on Windows Azure Cloud or on-premise. And to summarize, if you follow the security best practices on Windows Azure SQL Database and complement that with GreenSQL, you get a complete database security and compliance for Windows Azure, which can kind of provide you a peace of mind running your applications and putting your data in Windows Azure SQL Database. So I do want to thank you for listening, and I would be very, very happy to answer any questions that you may have on SQL database security. You have my email address here, so you can send me questions also after this webinar. And now I want to review the questions on GoToMeeting, and I will unmute those attendees who want to ask questions. Questions, anyone? Please raise your hand using GoToMeeting. Okay, I see one question, whether this webinar is recorded, and the answer is yes, it is recorded. And as I said, you will be able to get the slide deck after the presentation as well. So we will send you with a link to our YouTube channel to be able to watch this webinar from start. Okay, I'm waiting for more questions. Okay, I see that people asking for a live demo of GreenSQL, so I may be able to do something right now, but just please contact us after the webinar, and we will schedule a personalized session with you to focus on the things that may be interesting for you. Okay, I don't see any more questions, so I'll try to do a quick live demo right now. So what I'm going to do is I'm going to just run GreenSQL against Windows Azure SQL Database. So what you see here is GreenSQL's management interface. I'm logging in. This is GreenSQL's dashboard. And what I'm going to do now is I'm just going to connect to Windows Azure SQL Database. Very simple. So I'm just entering a logical name for the connection. It's going to be Windows Azure SQL Database. As I said, the product supports a few databases. So this is a Microsoft SQL Server. Now what I'm going to do is I'm going to insert the host name of the SQL database on Windows Azure. What you usually want to do is you want to copy this information from the management portal. This is basically the host name provided by Microsoft. I'm using the default port and I want to connect to the master database. I already have a login called GreenSQL. I'm just going to type in the password. And what I'm going to do now is I'm going to check the connection. What happens now behind the scenes is GreenSQL will automatically install what's called a proxy server, which is going to run on my server. And it's going to be listening on port 1435. And then what I'm going to do is I want to run the applications against port 1435. So let me check the connection. Connection succeeded. Now I'm connected to SQL database. GreenSQL instructs me to point the application to the proxy server that I defined. So what you see here is GreenSQL proxy. All the applications are going to connect to Windows Azure SQL Database using GreenSQL proxy. So I'm going to hit finish. And what I'm going to do right now is I'm going to run SQL Server Management Studio. And what I'm going to do is I want to show you how SQL injection attempts look like and how dynamic data masking works. So let me first connect directly to the Windows Azure instance. I'm just putting in the host name with the user GreenSQL. I'm hitting connect. Now I work over the internet. I can see my SQL databases in the cloud. I want to work on this database. It's called AdventureWorks. It's a sample database which you may all know. What I'm going to do is I want to run two sample queries. One is going to be a sample query that implements a SQL injection, and the other is just a simple select. So okay, so this is a SQL injection attempt. Basically, I'm just taking a simple select and I'm adding an expression that will always be true, followed by a semicolon, and then trying to steal data from a table called fact finance. This is not something that people usually do in SQL, but they will usually fill in a web form that will generate this SQL. So I'm just going to execute it right now. And what you can see is that you get the results from the dim customer table, the first table, and then you will get a result set also from the fact finance table, which you didn't want to get initially. The other thing that I'm going to do right now is I'm going to run a second query, which is a very simple query. So I'm just doing a select everything from the dim customer table. You see the data as is. And what I'm going to do right now is I'm going to go back to GreenSQL, to the Database Security tab, and I'm going to look at a database security rule that basically provides an intrusion prevention on SQL injection attempts. So I have this rule already defined in advance. What I'm going to do is I'm going to go back to SQL Server Management Studio. I'm going to connect to the application using the GreenSQL proxy, which is what you want to do if you want to use GreenSQL on Windows Azure SQL Database. So I remind you that by connecting to the instance, I already have GreenSQL software running on my local host on port 1435. I'm going to connect to SQL Azure through the through that GreenSQL proxy. As you see here, I have a second connection. I can see the list of databases, and what I'm going to do is I want to run the same SQL injection attempt against the AdventureWorks database. So let me do this. Hold on. Okay, sorry, that was the connection to Windows Azure directly. This is the connection to Windows Azure through GreenSQL. And what I'm going to do is I want to rerun. Sorry, I'm just going to copy and paste that. And what I have defined in GreenSQL is to block this any SQL injection attempt and to return an empty result set. So let me go back and execute a query. And what happened is GreenSQL detected that there is a SQL injection attempt and blocked it. If I go to the logs option in GreenSQL, sorry, the intrusion logs option, I see that GreenSQL blocked a SQL injection attempt. I can see the query, and I can see the reason for the block. So I can see all the forensics, the originating IP, user, application, etc. So this is a demo of how GreenSQL blocks SQL injection attempts of application trying to access Windows Azure SQL database. The other thing that I'm going to do very quick is to show you the dynamic data masking capability. What I'm going to do right now, I'm going to define a rule that will mask sensitive data. So I'm going to create a new rule. I already have GreenSQL detected the database here. I have many databases defined, but this is the Azure databases that GreenSQL detected. Now I'm going to walk through the schema on the database, and I want to go to a table called dim customer, which for this purpose is the sensitive data, and I want to take the email address because this is my most valuable asset, and I want to choose that column, and I want to mask this column. It's an email based column, so I want to do basic email masking. There's a couple of different masking options on GreenSQL. And what I'm going to do now is I'm going to create this rule. So you see here the fifth rule, is doing basic email masking on this column. I did not touch anything on the database side. I did not change any of the application code. I don't have the access to SQL Server Management Studio source code. So what I'm going to do right now is I'm going to copy the same query, which, as you can see here, just queries all the columns of or some of the columns of dim customer table, and you can see the full email address list from this table. I'm going to copy this query to the window running against Windows Azure, and I'm going to execute it. And what you can see is this is the basic email address masking. You can see that all these email addresses are masked. You can see just the first and last letter of the name and the domain name. You can choose to do full email address masking, which masks everything. You can mask credit cards, names, any other field of your choice that is sensitive. And this is done just by defining a simple rule in GreenSQL. Again, no application code changes, no database schema changes. Okay. So I do want to thank you again for joining this webinar. I hope you found it interesting. We have a Windows Azure SQL Database page on our website with some more information. There's also a data sheet. And you can also always contact me or our support team for further questions. Thank you again, and goodbye.